All right, ladies and gentlemen, we're going to round out what we're doing with triangle congruence with this last section, Cpctc, in which is section 4 or 5. Not the last section of the chapter, but we're kind of rounding out what we're doing with triangle congruence. So let's first review some triangle congruence with this first example, okay? So remember, think about unmarked congruences. Think about how we can prove triangles are congruent. And I just noticed the printout had a little error here. So for some reason, the icon didn't print out. In this little rectangle, that should be the congruent symbol. Let's just put that in. So you really want to think, how can I prove triangle ABD is congruent to triangle CBD based on what we've done before? So remember, you've got those 5 choices, right? We can do SSS, SAS, ASA, AAS, and also HL. Okay? So looking at what we have here, how would we prove ABD, that triangle, is congruent to CBD? Well, think about what other information are we given? What can we use, right? Clearly, I don't have congruent hypotenuses, so I know I'm going to strike off HL. I've got at least this right angle to deal with, so I'm going to strike off SSS. So remember what we talked about in class? Think about taking things off this list and also look for some unmarked congruences. So if you take a look at this, remember BD is congruent to itself by what reason? Hopefully you remember that's the reflexive property, right? So that's my reflexive property of congruence. So once I see that BD is congruent to itself, we can show that triangle ABD is congruent to triangle CBD by what reason? Well, you guys are seeing this is SAS, right? Because we've got the included angle. We know this is also a right angle because it's a linear pair, right? We know all right angles are congruent. Then I have the side AB and the side CB and the side BD, right? And the included angle, the right angles. So just a quick review. Hopefully you guys saw that SAS would work here. But the idea today is to take it one step further. Now that we know triangles are congruent, what else can we say about them? And this is something we actually talked about at the beginning of the chapter. So we're bringing our ideas back to congruent figures. So since the triangles have now been proven to be congruent, we know that their corresponding parts are also congruent. And that's what Cpctc means. All right, so for example, if we look back up at triangle ABD and CBD, so I'm going to just redraw it right here. Not bad, looks like this. What are some corresponding congruent parts? So we know, again, this was the right angle. These were congruent, right? And it was ABCD, all right? So just a quick check there. So A, B, C, and D. So since we know triangle ABD is congruent to triangle CBD, what are those corresponding congruent parts? Well, remember, here's a hint. We can always draw the triangles separately, right? What do I mean by that? I mean just split it up. So I can take this and literally just make them 2 separate right triangles, right? Here's A, B, D, and here is CBD, right? And this is where the right angles would go. So we would know the corresponding congruent parts are what's in the same position. So for example, since we know that the triangles are congruent, we could say which angles are congruent. Oh, we know angle A and angle C. They're in the same position, right? Angle ABD and angle CBD. Notice I'm using those 3 letters because that angle here in the original diagram's got more than one angle here. So I want to make sure I'm very clear. Right? We also know that angle ADB is congruent to angle EDB, and so on, right? So we know BD is congruent to itself, AB is congruent to CB, and AD is congruent to CD. right? And we know that because our triangles are congruent. That's something we talked about way back in section 2. And we're just bringing that back with our triangles. So if I asked you not to prove triangles congruent, but prove their parts are congruent, we can use what we call Cpctc. So sorry, excuse my dog for a moment. Okay, so again, we know this from earlier in the chapter. So we know that corresponding parts of congruent figures are congruent. So here we're saying corresponding parts of congruent triangles are congruent. And that is literally Cpctc. So all we did was we make an acronym out of it. So just taking the first letter of each of the important words, right? C, P, C, T, C. So that is all there is to it today. So again, Cpctc. I think corresponding parts of congruent triangles are congruent kind of rolls off the tongue, so I'm okay if you write that whole thing down too. But you can also do Cpctc. If you mess up and say CPC, CT or something like that, I'll know what you mean, so don't freak out too much about that. But remember, you have to use Cpctc after you know triangles are congruent. And again, sorry, those congruent signs for some reason did not print out. So down here, it should have been AD is congruent to CD. And same thing here. And that important note, again, you need to know the triangles are congruent before you can use Cpctc. So we still have to do SAS, SSS, ASA, etc., etc. All right, so again, you want to make sure you have that note down. You have to show the triangles are congruent. You cannot use Cpctc to prove triangles congruent. All you can say with Cpctc is that corresponding parts of congruent triangles are congruent. Okay, can't say that enough. Every year I have someone trying to use Cpctc as the congruent reason. Not going to work. Okay, so if we use the information again here in this diagram, and now instead of trying to prove the triangles are congruent, we're trying to prove the corresponding parts are congruent, all we need to do is simply add in one last step. So let's actually do a formal proof here so you can see what it looks like. So I'm going to set up my statements and reasons. Remember, you can do a paragraph proof or a flowchart proof. It's whatever you want. And then if you look at what I'm given that AB is congruent to CB, right? We are given that angle ABD is a right angle. Okay. I know that angle ABD and angle CBD are linear pair. And that's all from the diagram, right? So what I can do from that is basically flesh out that SAS proof from earlier. So since they're a linear pair, we know that they're supplementary. Your linear pair theorem, which means they add up to 180. Oops, I forgot the other angle here. So let me backtrack for a moment. So ABD and angle CBD are supplementary by your linear pair theorem. That's linear pair theorem. Okay, which means they add up to 180 by your definition of supplementary. So see how it all kind of flows? And then since I know that angle ABD is a right angle, we know the measure of angle ABD, 90 by your definition of right angle. So then I can substitute and say 90 plus measure of angle CBD equals 180. All right, and then I can go ahead and subtract. Step 8. and say that the measure of angle CBD is 90. All right, it's getting really messy. So that's subtraction and above is substitution. And let me scroll down to get some more space. That again, so subtraction, property of equality. And then since we have two 90-degree angles, we can say that they are congruent, right? Substitute again. Sorry about that. All right, so again, we have our two 90-degree angles that are equal, so I can substitute and make them equal to each other, which then leads to being congruent. Sorry, my dog is on a roll today. So again, since they're equal, they are now congruent. Right, by your definition of congruent. Notice how I'm throwing in a lot of our older stuff to help you kind of start thinking about reviewing for the final, right? So think about some of these other reasons. Okay, I'm going to finish this up here. So remember what we said earlier, we've got our sides, we've got now our angles. So what we need is the other side. So we said BD is congruent to itself by the reflexive property. So then I can say the triangles are congruent by SAS. Okay, so remember, the last thing we can do is Cpctc. So since I don't want to stop with the triangles being congruent, I want to show that these sides are congruent. AD is congruent to CD. I'm going to add that at the very end. And that is Cpctc. Right? So this is where Cpctc goes. It goes after you prove triangles congruent. All right? So notice how, again, nothing else is really different. We're just adding in that last little step. So look very carefully at what you're trying to prove. If you're trying to prove triangles congruent, stop with SAS, ASA, whatever, right? But if you're trying to prove that the parts are congruent, then we want to keep going and we want to use Cpctc. All right. So that is it. Come back to class with questions. We'll be practicing this before your quiz.